Welcome to Hong Kong. We're on our way to visit our factory in mainland China. As you can see, the airport's behind us and we're hundreds of feet in the air, and Drayton is scared to death. But that's okay because this tour is 100% safe. We're going to see all the manufacturing processes from molding to painting, printing, packaging, final assembly, and we'll even visit subcontractors to see things like how the PCB boards are made. So when we finish this video, you'll know everything there is to know about how we do things to bring you the best railroad, road number, and era-specific models. Stay tuned and join us on our journey. After we place our purchase order with the factory, a detailed write-up is created for each department, including molding, printing, painting, and final assembly. This document is hundreds of pages long and takes about 30 days to complete. Once finished, subcontractors in the factory can start production. While our factory does most of the work in-house, some things do have to be subcontracted. Today we're visiting our PCB supplier. In my hand is an actual PCB board with all of the traces drawn. That's actually what is happening in the machine behind me. Let's follow the entire process and see how they're made. So the second step in the process is to actually add the electronics to the board. As you can see in front of me, it almost looks like a printer, and you'll see that the tape is moving as it goes into the machine. What it's doing is feeding each individual electronic component into the machine to be placed on the board. So the final step is to heat all the components up so that all the chases will flow and all the components are soldered together. This is the machine that does that, and it's several hundred degrees. The next step is to make sure all of the components are soldered correctly on the board, and that's what's going on behind me. After the PCB board is created, there's a few more steps in the process. Going on behind me, this gentleman's adding the 2 supercapacitors for the power pack. We're the only manufacturer including supercapacitors in all of our models at the rivet counter level and above. Also, we're soldering on the lights, and depending on the version, it depends on what lights are going to be soldered. So that's going to be things like headlights, number boards, in this case an SD40-2 with class lights, and then the final step is to make sure that all the lights work. That way when it's installed in the locomotive, everything works perfectly. When we started ScaleTrains.com, we challenged ourselves to push the limits of our favorite hobby. One of those limits was motors. We wanted to come up with a motor that was powerful, that could pull long trains, as well as silky smooth throughout the power curve. This is the motor we came up with. In my hand is the beginnings of a new motor. As you can see, the armature's here, it's been insulated, the shaft's installed, the commutator's there. The next step in the process is what's going on behind me. As you can see, she's running wire back from the machine and then actually spins the copper wire onto the armature. You know, it's incredible that something so small is so important when it comes to a locomotive. There's a lot of different processes that make a motor perform extremely well. Those include the number of windings on the armature, the type of wire, and the thickness of the wire. How polished is the commutator? But one of the most important steps is getting the motor balanced. Our motors go through 2 balancing processes. One you see in front of me right here is when the armature is totally complete. The last one is when the flywheels are installed. It goes through another balancing process. It's that balance that gives you that silky smooth control and that ton of pulling power. So here's the final step. This is balancing the motor with the flywheels installed. You know, we want to give our customers the absolute best value, and that's why we use the same motor in both the operator and the rivet counter brand. This gives you super precise motor control and stump pulling power. So this subcontractor makes the wheels on the train go round. I'm holding in my hand a piece of bar stock. This is the beginning of a wheel set. And what will happen is this is fed through a machine that's going to cut it to the appropriate length. It's going to cut the piece of steel down to the right size, so the flanges, and then it's going to put a hole in the wheel itself. The next step is to go out to electroplating, where it's going to put the black color on the wheel, and then it comes back here for final assembly. In addition to making locomotive and freight car wheels, the metal supplier also produces the metal gear assemblies. Here, an arbor press is being used to insert a gear onto the shaft for a locomotive gearbox. So we're here in the warehouse where our steel molds are stored. It's really important that the warehouse is dry and cool. That way the steel doesn't rust. While subcontractors work on the electronics, metal parts, and more, manufacturing begins at the factory too. Molding plastic parts is the first step. Here we see a hardened steel mold for locomotive handrails. To ensure our handrails are straight, we create a handrail mold for each color. This allows for shrinkage when the plastic cools. The factory uses both virgin and recycled plastic. Plastic from sprues and parts that do not pass inspection are fed through a grinder to make pellets, otherwise known as regrind. As you can see, the steel mold halves come together and molten plastic is injected into the mold. After the halves retract, the mechanical arm reaches into the machine, picks up the part, and places it in a bin. This is one of the few robots at the factory. Most of the molding machines at the factory are operated manually. As you can see, the work area is neat and clean. The operator initiates each molding cycle and physically removes the part from the machine. He then inspects each part for what's called a short shot. He's making sure the plastic flowed evenly throughout the mold and formed correctly. On average, a locomotive body can be molded and inspected in about 1 minute. For a run of 3,000 locomotives, that's 3,000 minutes or 50 hours just for the molding process. This does not include the setup or teardown time for each body variant. After we finish molding, it's time to prepare the bodies for paint. In this particular instance, we're taking and we're making sub-assemblies. This is a -9 cab, but it works exactly the same way for all of our other products. For the -9, you've got a separate number board housing, a separate nose door, and what this young lady's doing is actually installing an etched metal plate. That represents a builder's plate. So when the production's finished, you'll have that nice shiny metal look. So if you've ever seen one of our rivet counter undecorated models, they look like Swiss cheese. One of the unique things that we do is whenever it's possible, we design our models so that there's a pin in the tooling. And what that means is every grab iron, every part is exactly straight. You don't have to worry about an air hole in one place or another. Sometimes though, there's holes that we do have to drill. We're drilling holes for snowplows. You'll also see us drill holes for things like horns, beacons, and other parts that are going to move on the locomotive or the freight car. So as you can see in front of me, the young lady is actually cutting away the sprues that are left inside the body cavity. The reason they're there is to help the plastic flow during the injection molding process. Now that the molding is done, the sub-assemblies are ready, and all the detail parts are there, it's time to head to paint. Let's see how they do it. Our factory uses an acrylic or water-based paint. Since we're mass-producing models, an automotive-style paint gun is used to quickly apply the color. The spray booth has a water curtain to catch any overspray. Once the body or part is painted, it's set aside to dry. So as you can imagine, during the production process, there are literally thousands upon thousands upon thousands of small parts that have to be painted. To speed up the process, what the factory does is they take masking tape and tape to these large trays. Next, they affix the plastic parts. The tray then goes to the paint shop where the appropriate color is sprayed. Once dry, it comes back, the masking tape's removed, and then new masking tape is put on, the part is turned over, and the other side is sprayed. This saves a ton of time in the painting process. What's in the box? Have you got a good guess? Well, if you said lift rings, you're absolutely right. These tiny lift rings, there's literally hundreds on this frame. Before they can be applied to the locomotive, this has to be painted, and then the lift rings removed. Can you imagine the tedious process to make that happen? So as you can see here, this young lady is actually putting grab irons onto this foam pad. And what that allows us to do then is when this goes to the paint shop, they can all be sprayed at the same time. Once it's dry, each one's taken out and the long leg is cut off so that they can be inserted into the locomotive. As you can see next to me, there are literally hundreds and hundreds of light bars. And to make sure the light shines in just the right place, check out what has to be done. So a bar is used and there's masking tape wrapped around the bar, and then the light bar is actually affixed to the tape, and then more tape is ran along the top. The reason for this is it makes sure that the paint doesn't cover the end of the light bars. Then they're taken to the spray booth, they're painted silver, and that way the light is going to reflect on the inside of the light bar and only come out on the ends. After the base color is applied, it's time for masking. So here the base color was yellow, and then we come back and we do the blue and the orange. In this case, we're spray painting the orange, and you can see there's the very crisp lines. That's created by the paint mask. We could even get the unique shape for the C in the Chessy Cat. So the body's inserted into the mask, and he's pressing very tightly to get those sharp, crisp edges. He's going to work his hand down along the mask to keep the pressure very tight. About every 5 times that a body is sprayed, he's going to have to take the mask off and clean it to ensure the edges stay sharp. Sometimes the level of detail is absolutely unbelievable. You know, as the guy who writes the checks, I have to wonder what product development is thinking sometimes. Take a look at this. This is a special clamp mask that's created to do this very tiny detail to paint the silver on this air filter. Now, of course, that's what makes our models unique and what makes them so awesome, but holy smokes, this process is unbelievable. We even go to a ton of effort on the operator model. In my hand is an SD40-2 cab interior, and at the very back of the engineer's side is a step. And my right hand is the mask, and what happens is it's inserted into the mask, and right here you'll see that step. When it goes into the paint booth, that's going to be sprayed so it's the appropriate color. Unbelievable the amount of detail we go to, even in the operator brand. So as you can see, there are a ton of steps in the painting process. Between each step, the bodies are stored on racks just like these. Next to me, the Chicago Northwestern SD40-2s and the BN SD40-2s. When the time's right, they'll come off these racks, they'll go to the appropriate paint booth so that they'll look just right when they get to you. So after painting, it's time for pad printing. This is when the model actually starts to come to life. Let's check out the processes and see how it works. Before we start printing, we have to create the printing plates, and it all starts right here. On this film, you'll see the road number for our upcoming flat car that hauls rebar. And the way this works is this film is transferred to a metal plate using a chemical process that etches it into the metal. Right here, we're actually looking at number boards for one of our locomotives. So we're often asked, why do containers cost so much money? They're just a box. Well, it's called printing impressions. There's a lot of work that goes into the printing process. Today we're going to follow a DM&E SD40-2 in the Mount Rushmore paint scheme all the way through the printing process and see how much work goes into making the model as accurate as it can be. So she's now loading a body onto the jig, and we're going to watch 5 colors be deposited on that body. In this case, white, blue, yellow, black, and green, and you're actually going to be able to see the Mount Rushmore logo come into vision right before our very eyes. Now she's going to remove the body from the jig, and she's going to take a very close look at it with a magnifying glass. This is to make sure that everything is registered. In other words, no fuzzy edges. So now that we've got the Mount Rushmore logo on the side of the body, it's time to add the red, white, and blue banner. Here in front of me, you'll see this machine's depositing 4 colors: black, red, blue, and white. Altogether, that's 9 different colors to create this unique logo. When it's all done, they'll reset both machines and do the 9 colors on the other side. So that's a total of 18 different printing impressions to get this one unique logo on one locomotive. So final assembly actually occurs on the production line. And on the production line, there's going to be at least 50 different stations with workers at each station doing sub-assemblies that come together to make the final locomotive. Here we're in a special room so we can get it up close and personal and see what's happening. This particular worker is assembling the DM&E SD40-2 cab interior in the rivet counter series. There's actually 7 individual parts that make up this particular part of the locomotive. You've got the front wall, the back wall, 3 seats, and the control stand on both sides. As you can see here, she's applying very small dabs of glue on the underside, and that way none of the glue will leak through and you'll actually see in the cab interior. If you're like me, you're a fan of all the hard work that goes into our models. Here we see dynamic brake and radiator fans on an etched metal frame. Of course, this has to be painted before it can be assembled. As we look down at the table, she's actually putting these fans on the DM&E SD40-2. Very delicately, she's placing the fan in the grill itself, and then she's going to take some glue and finally touch around the edges to make sure that it's not visible when the final product is ready. If you think about it, in our example of 3,000 locomotives on a production run, that's 5 fans per locomotive. That's 15,000 different fans that have to be installed before this shipment is ready to leave.
Thankfully, our factory workers are highly skilled at building model trains because final assembly is a meticulous process. Every single part is hand applied. A freight car can have more than 100 separate parts, and a locomotive over 300 individual parts. The HO scale big blow turbine has a staggering 800 plus parts. Using our example of 3,000 locomotives, that's nearly 1 million parts that have to be hand assembled.
DCC and sound locomotives require even more testing. Of course, we're going to test the light functions. In this instance, we're looking at a rivet counter Chicago Northwestern SD40-2. We're going to make sure the class lights work so we can cycle between red, white, green, and off. We're also going to check the number boards, make sure they're lit, and all of the headlights, both front and rear. In addition, you'll notice the sound is off right now. That's because we can test the coupler clank, the bell, the horn, and those other sound functions. And we'll test the prime mover eventually. While it's quiet, we're listening for the motor, we're listening for the gear train, and also the drivetrain. If everything sounds correct, and the sounds are correct, as well as the lighting functions, it's off to be married with the body.
The last step in the manufacturing process is final packaging. Each model is visually inspected to ensure it meets our high quality standards. Blemishes are touched up and fingerprints removed. The model is then carefully placed in its package and prepared to ship to our warehouse in Tennessee.
So the final step in production is getting everything ready to ship. As you can see, the workers are rolling out the pallets in preparation for the container to arrive. All the pallets are shrink wrapped. They have straps on them. They've got corner braces. And this is to ensure the models arrive in the best condition possible when they get to Tennessee. This process will take almost 5 weeks from the time it leaves our factory until you see us open the doors in Tennessee. So what's happening now is the final step. We're loading the container in preparation to ship it to Tennessee. The forklift's going to come up. He's going to put it on the container. There's a gentleman inside. He's got the pallet jack, and what he's going to do then is move that container inside. So here comes the forklift. He's going to put the pallet inside. Once he puts the pallet inside, the other worker in the trailer is going to move that pallet to where it needs to go so that it safely arrives in Tennessee. So after the truck leaves here, it's going to make its way down to the port in Hong Kong. After a few days, it'll be loaded onto a ship, and it'll make that long journey all the way across the Pacific Ocean, down to the Panama Canal, through the canal, and all the way up to Savannah, Georgia. At Savannah, it's going to be loaded on another truck and then come up to Tennessee. So the final step, your door first, is to shut the door. Ready? So the final step as we shut the door is this will go to customs in China. They'll put this bolt on it, and when we get to Tennessee, we'll cut it off. So here comes the truck. As you can see, it's a tight squeeze as he's leaving the factory. And as the truck passes by, here comes our last side of the container as it makes its 5 to 6 week journey to Tennessee. We wish it bon voyage.
We've had a great week in China. You know, as this comes to a close and I reflect back on the week, I've learned a ton, and I sure hope you have too. You know, we wanted to share this video because we wanted folks to see the efforts that our team goes to both in the United States and here in China to bring the best models possible. This is probably my 10th trip to the factory, and you know, I thought I had a pretty good idea of how model trains are made. I really didn't. You know, it's amazing to me all the effort the factory goes to. It's really hard when you think about the hundreds of pieces that can go into a locomotive or over 100 pieces that go into a freight car to make sure every piece is on straight, to make sure every piece is correct, the paint colors are right. I mean, I could go on, you know, and even being able to see some of the sub-assemblies, like the PCB boards where they were testing the lights on the Chicago Northwestern SD40-2s. I had no idea that that happened. So, you know, we hope that you've gained as much appreciation for how model trains are made as we have. And you know, if you'd like to learn more about our products, visit us at scaletrains.com. Thanks so much for tuning in.